All right. Hi, Brenda.
Brenda, I didn't do too hot on the quiz.
All right. Now, the thing that we are talking about here is, let's see how this works. Oh, I'd like for that to be a little higher. Okay, so in your notes, that's good. We're going to be talking about graphing linear equations. Now, we've already done this. You did this last year, and we did it at the beginning of this year. Okay? But think about what Chapter 12 has been. Chapter 12 has been less than and greater than problems, right? It's been inequalities. That's really what Chapter 12 has been. First we had wall problems. We went back and reviewed wall problems with equals, and then we did them with less than or greater than. Then we did the bar problems, and we went back and reviewed the bar problems with equals, absolute value equations, and then we did them with less than or greater than. So now, we're going to do the same thing here. So today we're going to go back and review graphing these linear equations, and then we're going to do them with less than and greater than. That'll be the new stuff. So for today, we're going to go back and review the stuff that we did in graphing linear equations. So, here's what one would look like. Okay? So let's write this down. Let's put in, let's do, oops, 3x plus 2y equals 4. 3x plus 2y equals 4. This is the kind of equation that we need to be able to graph. And you can see, and you could, on your in your notes, it would be good to put a grid like what I have here, or an x and y axis. And remember, this axis here is called the x-axis, and this axis over here is called the y-axis. Now, let's brainstorm a minute. What do you remember about graphing linear equations? Nothing. Okay. What else? Come on.
Down is negative. Up is
Okay.
positive,
Up is
right
positive. Down's negative. To the right,
Positive.
positive.
To the left.
Left, negative. I remember that. What about these x and y type equations? Slope was a term we used, right? Slope. Rise over run. Slope was rise over run. We like to have slope as a fraction. I agree. Those are good things. Okay, what about the equation? Remember doing anything with equations like this?
Can't mix x and y.
Well, we can't add x and y's together, right? Those are apples and oranges.
Looks like a wall problem.
And we did some stuff with kind of a wall problem. We did something with a wall problem here. You know, whenever we do a wall problem, we try to get something by itself, right? Do you remember ever trying to get something by itself here? The y. We tried to get the y by itself. Okay? Why did we get the y by itself? Well, let me go to a different page here. Oops. Let me insert a blank page here. And so in your notes, you might want to write this right here. Y, I don't want that in red. Let me erase that. Y equals mx, and this could be, you know, in a little different spot in your notes or whatever, where you got some room, because we're doing that one problem there, so you probably want this separate a little bit. Remember y equals mx plus b?
Yeah, I do.
Sort of, vaguely, okay, that's why we're reviewing it.
I remember y equals b parentheses x.
Okay. We're not going to have to do that very much in this next section, but we had something called point slope form. Don't write this down, but it was m. It was x minus x1 plus y1. Remember that? That was called point slope form. And if we had a point, we plug it in there. If we had slope, we plug it in there. But that was to write the equation. In these problems, I'm going to give you the equation. What you're going to need to do is graph it. okay? What you're gonna need to do is graph it. So let's make sure we get this written down, okay? All right, so we got y equals mx plus b, like so, okay? Yes?
What's with the B?
What's with the b? We're going to talk about that, okay? The b is just a number. The b is just a number. You're going to see here in a minute. Anybody remember what the m was? That was the slope. That's right. That was the slope. The number in front of the x was the slope, and as you've already said, we thought of that as rise over run. So that would be really important to write in here. Okay? And nobody remembers what the b was. No, yeah, you think of like triangles, we use b for base. Okay, well let's hold off on that for a second. Let's come back to this problem here. Okay, so coming back to this problem, we've already decided that we want to get the y by itself. Now, why do we? Because we want it to look like this, right? We want it to look like this, so we want to get the y by itself. So, how would I get the y by itself? I would get rid of the 3x by putting a negative 3x. Everybody write that down. Everybody do that on your paper. Take away 3x from both sides. Now, let's think about what happens. I can put the wall in here because it really is like a wall problem. Those cancel, and I would usually put a line under it. I did that a lot, yeah, absolutely. So what are you left with here?
Divide by 2.
Well, wait, let's wait, yeah, we're good, but let's be careful here. What do I get right here? 2y. And then, we were really picky about how we wrote this too.
Negative 3x plus.
We want to write the negative 3x first plus the 4. Because, again, look at this back to this page, we want to have the mx part first and then plus the b. Okay, so we're kind of picky about that because we can't put the 4 with the negative 3, right? Because one has an x, one doesn't. Apples and oranges, like terms. So we can't put those together. Right, Kayla? I mean, if you'd be tempted, yeah, you wanted to, didn't you? Yeah, we can't put those together because the 4 doesn't have an x on it. Okay, so real picky. Okay, then Justice says we're going to do what?
Divide by 2.
Now we're going to divide both sides by 2. So I'm going to divide this by 2. And what about over here?
1 and 4.
No. We got to divide each piece
So it's fair.
by 2. Yeah, I mean, we got to divide the whole side, both sides by 2. So since that side has 2 things on it, you have to divide each of them by 2. So we get y equals. Now, here's another thing that we'd run into. Hope grab your calculator, as most of you will.
It'll have to turn into a fraction.
Take negative 3 divided by 2.
It has to be a fraction.
You get negative 1.5. We don't like that.
There's no other point.
We don't like negative 1.5 either. We don't want a mixed number. We want a fraction. Make sure you know how to grab your calculators and make sure you know how to do that.
Got it.
Negative 1 and 1 half.
Negative.
We don't want negative 1 and 1/2. We want negative 3, Hope.
Oh,
We want a fraction. 1.5 is not a fraction. It's a mixed number. We don't want a decimal. We don't want a mixed number. Why do we want a fraction for our slope?
This will come out.
Because it's rising.
Rise over run. We want our slope to be rise over run. We want it to be a fraction. Okay, what's 4 divided by 2?
2.
Okay, now if that comes out a mixed number, that's okay. That number's okay to be a mixed number. But the number in front of the x, the m, the slope, rise over run, we want it to be a fraction. Okay, good job. We just got a big part of our job done right there by doing that.
I'm confused.
Now we gotta
What?
put it in that other.
Confused about what?
I'm not used to that.
I used to what?
Because I'm used to just subtracting 4.
But you can't, and the beauty of this is it's going to be this way every time. So it's not like you got to pay, that doesn't have an x on it, right?
Yeah.
And this one does, and so you can't put them together. You can only add or subtract things that are alike. So you cannot subtract those. Now here we can, see these both have an x, right? And so those cancel that. But here, you're going to have 2 different things every time. One's got an x, one doesn't, so we can't put them together, so we write 2 things. Okay? Now, Okay, and we'll do a couple more of these to keep practicing as we go. Now the question is, how do we graph that? Now, there were about 3 ways we learned to graph. Now, I'm not going to confuse it by going through all the different ways. But we're going to do 2 of them. We're going to talk about 2 of them, and we're going to actually narrow it down to 1, probably the fastest one. So I don't want you to write this down right now, okay? But I'm going to, off to the side here. The very first way we learned to do these was to make an XY table. You remember that? Now, if you think that's the only way you can figure out how to draw a graph, heck, do the XY table. But give me a chance here, before you write that down, give me a chance to show you the other way, okay? And you guys have done it before. We've done it. You just aren't remembering it yet, just right now. Okay, so just do this with me, but don't write it down. What did we do when we did our XY table?
Put X on that side and Y on that side.
Right, but what did we do? I mean,
Pick 2
we didn't pick 2 numbers. We picked X's.
Yeah.
We just picked numbers for X. And how many?
3.
Man, I think I said 4. I think I always said 4. What did I say was a good one to start with?
-1 and 1.
No, even better than that. 0. 0 is always a beautiful one to do. So I'm going to put a 0 in there for X. Now, what did I do with that 0 then?
Put in there.
I put it into this equation. So on your calculators, do this with me now. We're going to stick a 0 right in there for X. So let's take -3 over 2 times 0 plus 2. What do you get?
2.
Now that makes sense, because what happens when you take -3 halves times 0?
0.
You're always going to get 0. Matter of fact, you're always going to get this number over here. Oh, that's that B thing. Oh, hold that thought on that B. We're going to see something about that in a minute. Okay, pick something else that I could put in here. I could put in 2. Now, some of you said 1. If you remember, we talked about being smart about what to plug in here. Since you have a fraction here with the 2 on the bottom, your best numbers to pick for X would be numbers that 2 goes into, like 2 and 4 and 6 and 8 and stuff like that. Okay, so I'm going to do 2. So on your calculator, let's do it. What's -3 halves times 2 plus 1? You get what? -1?
-2.
Okay. Let's try -2. That'd be a good one to put in. So let's try -3 halves.
No. That
Okay,
answer's
try it
2.
again. You did plus 1. It's plus 2.
Oh, okay.
Okay, now let's do -3 halves times -2 plus 2. You get 5. And I said we should do 4 of them, so let's do 4. Let's pick one more, let's do 4. -3 over 2 times 4 plus 2 is what? -4. Okay, now I'm going to plot those. Now you guys don't plot them yet on your graph. Okay, so 0, 2 would be right there. And 2, -1 would be right there. And -2, 1, 2, 3, 4, 5 would be right there. And 4, 1, 2, 3, 4, 1, 2, 3, 4. And look at that, they line up. Right?
Also do like 2, the top 2 numbers.
What's that?
Like the 0 and the 2, I could just do the 2 and the -1.
Well, you could have, but if you plotted one of them wrong, then your line would go somewhere else. If you do 4, then you always can catch if you goofed up one. So that's why we always said do 4. And then we wanted to draw our line all the way through there. Right? Okay, now, I'm gonna undo my little line in there. Oh, what'd you say? Oh, okay. Well, anyway. All right, that was with the table. Now that is the long way to do it. I think I know you guys well enough to know you're not going to want to do the long way if you don't have to. Okay? So I'm going to remind you, and we're going to go back to this page right here. We said that this number right here was the slope. Remember the rise over run? We all agree with that? Look up here now. Christy, look up here. We all agree that this -3 over 2 is the rise over run? We good with that? But we didn't know what this number was.
That's your
Starting point. Look at this. Look, everybody, when you put a 0 in for X, you're always going to get this second number. You're always going to get this point 0, 2, which is this point right here. Let's come back to our notes. This point is, now here's its technical name. Write this in your notes now. This is called the y-intercept. But what we're going to remember it as is the starting point on the y-axis. That number is the starting point on the y-axis. So, all you need to know are those two things. And you can draw a graph every time, and it's a piece of cake. Now, you have to have the y by itself. So, this number's the starting point, and this number's the rise and the run. Now, let's go back to the problem we just doing. I'm going to do this in red now. So, once we had this y by itself, right? All we needed to do was look at the 2, and that is our starting point on the y-axis. So we just come right here and we put our starting point at 2. And then what does this mean for the rise and the run? That means the rise is -3. Cody, what's that mean if the rise is -3? Rise would normally mean up, right? But what's a rise of -3? That's going to go down. So the rise of -3 means we're going to go 1, 2, 3 down. Now remember, this is our starting point. And then we're going to do the run of 2. What's that mean? Whoa, 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 not up. Run is this way. So we're going to go right 2. So we're going to go down 3, right 2. Oh, look at that. And we'll do it again. 1, 2, 3 down, and 2 to the right. Look at that. 1, 2, 3 down, 2 to the right. Look at that. We would get those same points, and it's much faster. We wouldn't have had to go through this whole table, get our calculators out, and plug that all in. All we do is we say, hey, there's our starting point, 2, and then we're going to go down 3 over 2, down 3 over 2, down 3 over 2. We got it. Let's do another one. Okay? We're going to put this one in our notes. This time I'm going to make it easier. We're going to start with y by itself, because on your homework, some of them already have the y by itself. So let's do this. Let's say we got y equals 1/3 x minus 2. Let's say I gave you that equation right there. Y is already by itself. So what are you going to do? You're ready, aren't you? Change that to add the opposite. Your starting point is... Now, and I like what Justice just said. I always like to think of that starting point as a y-intercept. It's 0, -2. So we go right here, and we put our starting point. So draw this graph. Now, come on, you can put it right on that same graph if you want. But, okay, 0, that's our starting point, 0, -2. This number right here, that's our rise over a run. So what's that mean? Up 1 over 3. And keep doing it. Up 1 over 3. Up 1 over 3. Right? Now, yes, I'm just going to say, what happens if you run out of room? Because I always want you to extend your lines all the way through the grid. So, what happens if you run out of room going this way? Go in reverse. Yeah, it would be like doing this. It'd be like -1 over -3. Well, that's still a positive, right? That's still the same as 1 over 3 because it'd still be positive. So you go down 1, left 3. Down 1, left 3. Right? And they'll still line up. They'll still line up. There's your line. So if the y's by itself, it's pretty easy. All right. One more thing I want to remind you of. This doesn't happen a lot, but it happens every once in a while. We have a couple of special situations. What happens if you get the equation and there's no x in it? It's just y equals 2. And the other special situation we sometimes get is like x equals 3. There's no y in it, there's just an x.
Isn't that, I have a question.
Those are horizontal and vertical line. The question is which one's which? Here's how I remember this. If you've got y equals 2 or you've got x equals 3, right away you know they're special because they don't look like our normal one, right? They don't look like this one here with y equals mx plus b. It has just an x or just a y. So the way we do this is I just think of a quick little table. And this means the y is always equal to 2. You put any number you want in for the x, but the y always has to equal 2. What do you think about that? 1, 2, 2, 2, 3, 2. Pretty soon you see what? It's horizontal. What's the slope of that one? No, zero slope. Zero slope. Now, in red, let me do this one. Let me do x equals 3. Again, think of a quick little table. All the x's are 3, so that'd be like 3, 1, 3, 2, 3, 3. Well, let's plot that. 3, 1, that'd be 3, 1, 3, 2, 3, 3. See, it doesn't take you very long to see that that's a vertical line. What's the slope of that? No?
0.
No?
It's too steep.
That's the no slope one. No slope means it's too steep to have a slope.
I thought that's what I meant by smooth.
Yeah, you're right. It sounds like is a zero slope the same as no slope? No, because 0 is a number, right? Slopes are numbers. So 0 is a number, so it has a slope. It has a slope of 0. Right? It seems weird. I mean, it's flat. It has a slope of 0. So this one is slope of 0. This one is no slope. It's too steep to have a slope. Okay, so those are just two special situations. Those aren't going to come up very much in the ones we do. But this is what we have to be able to do. So on your homework, and we'll work a couple together here to get you off on the right track. Because remember, this is not the new stuff now. What we just did there is not the new stuff. This is the old stuff. We did it last year. We did it at the beginning of this year. We're going to throw in the less than and the greater than probably tomorrow. Probably a little bit tomorrow, and then we'll, or for sure the next day. And then, so we have to be able to graph these lines or we're not going to be able to do the new stuff. All right, so let's do a couple here together on this one.
You're going to work on a piece of paper.
Yeah, it might not be a bad idea to do some of your work on another piece of paper. Number 1, you've got a little room over to the left. Number 3 and 6, you've got a little bit room to the right. 2 and 5 there's not a lot of room because what do we have to do on number 1? We've got to get the y by itself. Do you see the ones at the bottom? Do you see those 6 problems at the bottom? Those are actually going to be easier, aren't they? I want you to ignore the directions. The directions say, in the top section, use the x and y intercept. We're not going to do that. That's our other method that we learned, and we're not going to do that, so don't even mess with it. We're going to do the same directions on all these, which is just to draw the graph. Okay? So let's do number 1 here. I want to do a couple on the top because they're the harder ones, because you've got to get the y by itself. So let's do it together here. So what do we do first? Not distribute. Subtract 1x. And I like to have a 1 in front of it because we know we're going to need a slope, right? So I'm going to subtract 1x from both sides. Now hope, here you go. What am I going to have here? I'm going to have y on this side. What am I going to have there?
Negative 1x plus 2.
Plus,
Negative 2.
perfect. Right? That was a part that was bugging you, wasn't it? Because you wanted to put those together, don't you? But you do not put those together because one of them has an x and one of them doesn't. So you just write it down, negative, and do the x first. All right, great. That's your first step. And that's your key step. Because now what do we got? Emilio, what do we got there once we get to there?
What do you mean?
What are we going to do now to draw this graph? We got that thing,
You go down.
and we got that thing. So what's this negative 2?
Starting point.
That's our starting point. So we're going to go right down here to negative 2. Once you get the y by itself, guys, you just got a starting point. And then what do we do with the negative 1 here?
Go down.
Look at this. Everybody look up here. It's not a fraction. We want rise over run, don't we? How do we make negative 1 a fraction? We just do negative 1 over 1. Right? So anytime you got a number in front of the x, it's not a fraction. Just put a 1 under it. So where are we going to go from our starting point? Down 1, right 1. Down 1, right 1.
You go up 1.
Now you could go backwards to give yourself a few more points. Now, here's my rule. I want you to draw your line because some of you guys started to get pretty chintzy with your number lines in the other stuff. Everybody look up here. I want this line to go all the way to the edges of the grid. I want you to extend your line all the way to the edges of the grid. Okay? Not just through a couple of points and stop.
Does it matter which way the arrow goes?
What do you mean?
So I look different than yours.
Well, then something's bad. Yeah, something's bad. Because right here, let me see your pencil. Right here, this is -1/1, right? It's a rise and a run, right? Rise and run. Okay, so here's our starting point. So the rise is -1, which means we go where? No, rise. Rise means up and down. Okay, but it's negative. It's negative. So rise means go up, unless it's negative, it means go down. Right. Okay, positive means up, negative means down. For the run, okay, so that means we're going to go down 1, and then what's the run? Positive means right, negative means left. So we're going to go right. So down 1, forward. Down 1, forward. You went up. You don't go up when it's negative. You go down. Okay? The bottom, listen, top number is rise, bottom number is run. And again, this is a key thing about algebra, and I say all the time, this is why it's so important to know each day, because it's going to come back again. You just keep adding things on. And so you've got to know one thing to go to the next. You've got to know one thing to go to the next. Now, yeah, sometimes we got to go back and review it. That's very true. Rise over run. Let's walk through number 4 here. If you've got it, keep going. Okay? But I'll walk through number 4 here for those that want to do it. Okay, I want to get the y by itself on number 4. So what am I going to do first? Subtract 2x, perfect. Subtract 2x, subtract 2x. Right? And that's going to cancel those out, and that's going to give me 3y equals Hope, you with me there?
Yeah.
What do you got? Negative 2x?
Plus,
Perfect. Then what?
That's the answer.
Now, the y is not by itself yet.
Divide by.
So we got to divide. And we're going to divide each of these things by 3. We got to divide everything by 3 on both sides. So now we get our y. Right? And what do you get? Negative. Negative 2/3 x plus 4. Okay, beautiful. Of course, we got if we do that part wrong, then our line will be wrong too. Okay, but now look. Now we're looking at these two pieces right here. Okay, this one is rise over run, but this one is our starting point, right? So what are you gonna do?
Start 4.
Go up 4 to start. Okay, what's this mean for a rise over run?
So we go down to.
Perfect. Which way 3? Right, because the bottom number is positive, so we're going to go right. 3. Then do it again. Down 2, right 3. And then that's all you can do because you kind of ran out of room. I mean, you could go down 2, but then you can't really go. So now you just draw your line. Okay, good. Good. Whenever you have that fraction, the negative would usually be on the top. So you just start by going up or down, and then you almost always go to the right. You know, unless you run out of room and have to go backwards, but otherwise. Okay? So, as we go into these new ones, these less than or greater than, you know, Justice, you'll love this. I'm not gonna be checking a whole bunch of that work. I want you to graph the lines. If you can graph it this way, if you can graph it, I mean, you want to make a table and graph it, you want to, whatever. Because we're gonna be adding on to it. When we make our lines, then we're gonna have to do some special stuff. There's gonna be some shading, there's gonna be some other stuff we have to do, right? But if our lines aren't right, it's kinda like what you have with that thing there. If you miss this down to this point, then there's no way you get the rest of it right, you know, so you're gonna. So we've got to get good at graphing these lines. Yes. Yes. Yeah, bell's gonna ring here in about a minute, so put the calculator. That would stay the same. Yeah, a lot of times those fractions do just stay the same.